Hey, John here, the Spoons Works. We're going to talk about the very basic introduction into electrical and electronics. The stuff that it's schoolwork, it's bookwork, but you have to know how electricity works in order to work with it. It's not magic. So we're going to deal with volts, amperes, and resistance. The electron flow is current, and it's measured in amperes. So the way to think about this is that think of volts being the force, or like a cannon, shooting a cannonball. Amps is your cannonball, it's your electrons moving through a really tight space. That tight space is the resistance. So you're going to, when electricity works, volts push amps through the resistance. That's the way Ohm's law works. And we're going to get into Ohm's law a little bit while we're doing this, because that's the best way I know to start this whole thing. Now, when you have an atom, you have protons and neutrons in the middle, and then on the outside you have electrons. Electrons are what move. That's literally what moves to produce electricity. Electricity. The movement of electrons, the flow. Now, one thing is, when you're talking about this, is that they literally flow. They literally move. Wire literally moves a little as electricity goes through it, because that current flow is literally electrons moving. It's subatomic particles, but it still causes movement. And you should know that we have conductors and insulators. So for conductors, what we're going to worry about doing, what we do mainly as electricians, either maintenance or construction, doesn't matter which, is you're going to worry about what good conductors and good insulators are. Semiconductors will be something we get to far later. Figure conductors, think about anything metal. Insulators, glass, plastic, rubber. But the other thing that can conduct is liquid. So you got to be careful around liquids. But in the case of what we want to do for work, we're going to use metal typically. The metal we're going to use most often is going to be copper. Not because it's the best conductor, because it's the best and most cost effective. It's the most cost effective conductor that is the best. Because silver is the best, and then aluminum. But we use copper because it is most cost effective and the best conductor for the price. It's most efficient. So we use copper typically as our conductor, and you'll find that we use glass, plastic, and rubber in different instances for our insulators. Conductor means that the electrons flow. An insulator, electrons don't flow. It's the most simple way of putting it. That's the basic way. That's why you can grab an extension cord while it's plugged in and not get hit, not get shocked. So conductors, insulators, volts, amperes, resistance is measured in ohms. Current is measured in amperes, and volts are volts. So that covers the basics. So Ohm's law, you've probably seen in your science classes in high school, is either V equals I times R or V equals A times R. Science and the technical fields. Now, in the technical fields, E equals I times R, because E is electromotive force. And it's the same when we're talking about it as when science types use volts as potential difference. It really doesn't matter which way you call it. It's still the same thing. It's still Ohm's law. So 1 volt pushes 1 amp through 1 ohm of resistance. That's the formula. So VA upside down horseshoe for ohms. It's the Greek letter omega. So if you want to remember it, is V equals A times omega upside down horseshoe, because that's what you'll see on an electrical meter. That's fine. You're going to get the results you're looking for. It doesn't really matter whether you're using the old Ohm's law or any of these versions of Ohm's law. They all work. So if you have a circuit, that has 30 volts and 2 amps, using Ohm's law, E equals I times R, can also be written as R equals E divided by I. So it would be 30 volts divided by 2 amps, going to give 15 ohms. Super basic way of doing it. Or if you have 6 amps and say 3 ohms of resistance, you're going to go 6 amps times 3 ohms equals 18 volts. What you need to do is remember which one to plug in where. Now, that's Ohm's law. Next thing we have is the power formula. P equals I times E. They're interchangeable. P is power. Power is measured in watts for us. So if I have something that's 6 volts and 12 amps, 6 times 12 gives me 72 watts. There you go. Ohm's law and power formula. Same thing. Now, if one of the things you can do is, if my givens are E and R, if I have E and R given in an equation, I can find power using this, because these are my knowns. I can substitute. I know that I equals E divided by R, and I can substitute that in. So then it becomes P equals E divided by R over E times R. And that becomes E squared divided by R. Basic algebra. These are the kind of things you're going to need to pay attention to. Some of that may have been too low to look at before. But there's the basics. With the formula, when you're working with Ohm's law, you just have to practice. If I have this and that, if these are the voltages, this is what I do. And this is, you're talking about, we're functioning in DC, all right? And we're not using AC, because in AC, there's different multipliers we'll get to eventually. But in here, right now, we're not going to start with that. So we're doing basic Ohm's law. We're just doing basic intro with this. Simple math. If you have any questions, go ahead and comment down below. I'll answer what I can, the best I can. But I think that most of you guys will pick this up pretty quick. If you're looking for things to do, you can always search and find Ohm's Law practice worksheets, practice journeyman's test, or practice apprentice test. Typically, journeyman's test, you need to know it. It might pop up in there. I've never had one on a journeyman's test. I've never had to use Ohm's Law. I've only had to use code book and then do some power factor and derating stuff. I've never had to use Ohm's Law. But you need to know this to get to the next levels, to understand power factor, derating, roughly, derating something else, but power factor for sure. And that should do it.